Hi, mathletes. Today we're going to look at combinations. And a combination is a way of selecting items from a group where order doesn't matter. So let's start by looking at a pizza. Let's say that we get to pick two toppings for our pizza. And we have four choices. We could have pepperoni, mushrooms, onions, and tomatoes. Does it matter if you pick the pepperoni first or the mushrooms first? No, it doesn't matter. It's still going to be the same pizza either way. That's what we call a combination. So let's say you're choosing your two toppings from a list of four. Again, you have pepperoni, mushrooms, onions, or tomatoes. How many different combinations of two toppings can you make? So, how many different kinds of pizzas can we have? Well, let's start with the pepperoni. We could have a pizza with pepperoni and mushrooms, pepperoni and onions, pepperoni and tomatoes. Then we could have mushrooms and onions. Now, I'm not going to say mushrooms and pepperoni because I already used that one. Mushrooms and tomatoes. And lastly, we have our onions, and I could have one with just onions and tomatoes. So it looks like I have six different combinations or six different types of pizzas. Now, did the order matter? No, it didn't matter. Again, it doesn't matter if I put the mushrooms on first or if I put them on second. So now let's say that we pick two random toppings for our pizza from the four options. All the combinations are likely equally. So we can say, what's the probability or the chance of getting our mushrooms and onion pizza? Well, we know that it would be 1/6 because there's only one mushroom and onion pizza and there's six total different types of pizzas. So let's say we have five different colored markers. We have red, blue, green, yellow, and purple. How many different combinations of two markers can you choose? Well, we could have red and blue, red and green, red and yellow, red and purple. We could have blue and green, blue and yellow, blue and purple. We could have green and green and purple. And lastly, we could have yellow and purple. So how many combinations do you have? Well, if we count them up, it looks like we have 10 different combinations. Again, does the order matter? No. A blue and a green is the same as a green and a blue. So now let's say that we pick two random markers from the five options. Are all combinations equally likely? Well, what's the probability or chance of getting a blue and a red? So how many are blue and red? And it looks like I just had this one because blue and red is the same as red and blue. I have one that's like that. And how many total do we have? We have 10. So the probability is 1/10. Again, there's only one blue and red, and there's 10 possible combinations. When figuring out all the outcomes, we can use a factorial. And a factorial is a quick way to multiply a number by all the smaller numbers below it. And we write it with an exclamation mark. Here's some examples. Now, this doesn't mean 3. It means 3 multiplied by 2 multiplied by 1, which is 6. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1, and the product being 24. And 5 factorial, the product is 120. So when we're finding all the outcomes and order does not matter, we call that a combination. The number of combinations equals this. Oh, that's kind of funny looking. Or sometimes we write it like this. Well, when I made the C a dark, see how I made it in bold? Because the C actually stands for combinations. Let's change that N. So the N is going to stand for the total number of objects. And the R? Well, the R is going to represent the number of objects that we selected. So now we know what all of the variables stand for. In mathematics, we have a formula for combinations, and it looks like this. Ooh, it looks a bit sophisticated. But we know now what the variables stand for, and we know what the factorials mean from the previous slide. Now, the formula for permutations looks like this. So what's the same and what's different? Just a reminder that permutations order does matter. And if you haven't seen my video on permutations yet, check it out because that'll help you to understand combinations as well. So let's do this pizza problem again. Now remember, we get to choose 2 random toppings from 4 options. And here's the list that we created earlier. It looked like this. And remember, we had 6 different types of pizzas. Well, if we use the formula, looks like this. Let's see what we know. N is the total number of objects. And the total number is we have 4 options, right? So we have 4 of them. And R is the number of objects selected. And we're going to choose 2 toppings. So now we can replace our N's with 4 and our R's with 2. And now all we have to do is simplify. So 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. 2 factorial is 2 multiplied by 1. The difference of 4 and 2 is 2, and it's 2 factorial. So now the denominator is 2 multiplied by 1, multiplied by 2, multiplied by 1. And now all we're doing is simplifying, and it looks like I have 6 different types of pizzas, which matches our listing. So again, another way to do it, using a listing or actually doing the formula. So let's say that we have 7 shirts. We have red, blue, pink, gray, white, plum, and green. And how many different combinations of 3 shirts could you make? Well, again, here is my formula. And N is the total number of objects. So let's see, I'm counting them. It looks like I have 7 total. And I get to select 3 of them. So now we need to replace the N with 7 and the R with 3. There we go. And now we're simplifying. Ooh, 7 factorial is a long one. Okay, and again, simplifying the denominator. And now all we have to do is multiply the numerator and the denominator and then divide, and I get 35 different combinations. Now let's look at this spinner. The spinner has 6 different colors on it. How many 4-color combinations can you come up with? Well, again, we have a total of 6 colors, so that's our N, and the R is going to be 4 because we only get to choose 4. So we're replacing the 6 with for the N and the 4 for the R. And now we're simplifying. And again, we're going to simplify the numerator and denominator, and the quotient is 15. So it looks like there's 15 different combinations. So remember, a combination is an arrangement of items where the order does not matter. It's the opposite of a permutation where it does matter. Factorials can help us calculate combinations, and we can figure out all the outcomes by making a list or using the formula. And the formula is actually the faster way. So there's our formula. And even though it looks a bit sophisticated, we know that it's not hard to use at all. I hope that this helps you understanding combinations. And again, check out the video on permutations. That'll help you out as well. And if you like this, watch some of my other videos. As always, thank you for watching.